Hello, I'm Shangjie. This video presents our work on document-level OpenIE with coreference resolution, or DOCOR in short. First and foremost, Open Information Extraction, or OpenIE in short, is a class of tools that extract relational tuple from plain text. Each relational tuple is typically made up of subject, relation, and object. By structuring plain text in the format of a relational tuple, it could be used for many downstream natural language processing tasks such as question answering and knowledge-based construction. However, OpenIE are not without its shortcomings. Existing OpenIE systems perform extraction on sentential level, mainly relying on sentence syntactic structure. This means that in the case of a paragraph or document, relations across different sentences would often not be drawn, especially when an entity is referred to using different expression across different sentences. This phenomena is called coreferencing. Generally, there are two kinds of coreferencing. Anaphoric referencing, where an entity is mentioned upfront before referred to in another expression, and cataphoric referencing, where an entity takes on other expression before it is introduced later in the text. Now let's see with an example what problem coreferences poses to OpenIE system. Consider the following sentence. Alice is a ballet dancer. She participated in a dance competition. Carol is a friend of Alice. She is the owner of a dance studio. From here, we get the subject in red, object in green, and the relation underlined. Building a knowledge graph out of this tuple will yield a knowledge graph as shown. The pronoun she, despite referring to two separate entities, have been merged into a single node. This unintended merger of nodes makes the relational tuple ambiguous and difficult to use in any downstream task. What we aim to achieve from this demonstration is to resolve such ambiguities with the help of coreference resolution tool. We'll use a news article from Singapore's news media outlet, The Straits Times, to facilitate the explanation of the concept related to this demonstration. How coreference resolution works is that it first identifies the coreferential mention within the document, then group them into coreferential cluster, where all mention in the same cluster refers to the same entity. From this short excerpt, 4 clusters were constructed. From here, the next step is to identify a term from each cluster that represents the entire cluster in order for us to be able to use the representative term to refine ambiguous relational tuples. In this demonstration, we propose DOCOR, a pipeline which integrates OpenIE with coreference resolution and a new method of identifying the representative term of each coreference cluster. DOCOR's system architecture is as shown. We first extract the coreference cluster. Next, we identify a representative term from each cluster, and then we extract and refine the relational tuple with the representative term, before we display the tuple as a knowledge graph on the web interface. For the coreference resolution and the tuple extractor, we used off-the-shelf tools. The coreference resolution tool is by Shi and Choi, while the tuple extractor used is OpenIE 4 by University of Washington. As for the representative term selection, we proposed a feed-forward neural network approach for this task. We first select a cluster we would like to process. We then encode each span using the SpanBird language model. Then next, we use a hidden state of the CLS special token as the span representation and feed it into a 2-layer feed-forward neural network to produce 2 confidence scores for each span. The score of class 1 is the confidence of the span being a representative term, while the score of class 0 is the confidence of the span being otherwise. The confidence score for each span is then converted to a normalized probability score using the softmax function. We then select the representative term by picking the span with the highest probability of class 1. In the case of the example, span 2, which is Singapore, would be deemed more representative than the term the Republic. The last component of DOCOR is the tuple refinement, which disambiguates the tuples extracted by OpenIE 4 with the coreference cluster and their respective representative term. Let's say we have these coreference clusters with their respective representative term indicated in green. From the same piece of text, these are the relational tuples extracted by OpenIE 4. We first identify all the coreferential mentioned within the subject and object of the tuples. After all the coreferential terms are identified, they are then substituted with the representative term of their respective clusters. Now that we have an understanding of how DOCOR works, let's switch over to the web interface to see DOCOR in action. The web interface has 3 components, a box for text input, and 2 knowledge graphs for comparison between the original and the refined tuples. Using the Alice and Carol example earlier, the knowledge graph will be as shown. We see that the refined knowledge graph no longer have an entity she, Rather, they have been disambiguated into Alice and Carol appropriately, resulting in a much more accurate knowledge graph. Docker could also be used to process a full article. To wrap things up, we presented a pipeline system which resolved much of existing OpenIE's ambiguity problem. For the implementation details and evaluation of our method, please refer to our paper. Thank you.